things started, this is a talk about doing some rather improbable things with Apache Spark. So how many people, is anyone in the room right now running Apache Spark serverless? Right, one person. Is it replicating what Delta Lake does? No, wow, okay. That's pretty impressive. So the reason why the talk is called Moonshot Spark is because serverless is really a strange and hostile and remote environment for Apache Spark. So just to give you a bit of background about me, I thought I was a software engineer, but I kept falling back down into the data. So finally, I realized that I was trying to fix everything at the wrong end of the data pipeline. And it was giving me a situation I can only call resting batch face. So I decided to go work with data. And that's how I wound up at Reductio. And if you want to see something about like what I really do day to day, you could see my Spark AI Summit presentation linked here. So just in general, what could be less well-suited to a serverless environment than Apache Spark? It loves a lot of memory, a lot of CPU, and having fast local storage and having fine-grained control over all of its resources. What does serverless offer? This list has a lot of great stuff on it, but none of those things pretty much. I mean, really, the reason why serverless is so seductive is because it's easy to reason about, and it's easy to compose, and it's supposed to be cheaper. I mean, it probably will be cheaper someday for some people, but you know, microservices are a nice idea, right? I mean, if you've ever dealt with a sufficiently large monorepo, the thought of turning it all into microservices is amazing, you know, and then also just, you know, turning all of this awful infrastructure into code that is somebody else ops is also amazing. So, you know, thinking of what I would want from Apache Spark and serverless, I want the ability to do what I do now, but I want it to be faster and cheaper and less troublesome. And I don't want to worry about having to granularly control my resources. And as long as I'm asking for a pony, I decided to ask that it should just integrate with popular logging and monitoring tools without effort on my part. Right, that's probably not going to happen. So, looking just in general at the paradigm shift of serverless, the whole idea is that it's supposed to let us focus on the application and be agnostic of where that application is going to run, that it's going to be a stateless function. And if you think of it, a Spark executor could be conceived of as a stateless function, right? I mean, in reality, it's not at all, but that's just because that's the way it's been written. That's not because it has to be that way, right? So, you know, if you think about what you control right now in serverless functions, that list is relatively small. You can decide to time out sooner than your cloud provider times you out. And you can also choose how much memory that you allocate up to a maximum of, what, maybe 3 gig. So that's compared with what most people running Spark clusters control. Number of cores per executor, amount of memory, shuffle partition, like all of this stuff, that's not very much, right? But it's kind of refreshing too, right? I mean, loads of people, if you try to Google about optimizing Spark or how you should optimize your Spark jobs, you find so much. It's a very complicated topic. Wouldn't it be great if you had far fewer knobs to turn, or if that were handled for you in some way? So as far as what you don't control, it's pretty much everything else. You know, how long you're going to depend on external services, and you don't have very much control over how long those take to respond. You don't have any control really over the reliability of the underlying infrastructure, except maybe going to a different cloud provider. And you know, really there's a variety of different times that cloud providers will allow functions to run. So, and there's a lot of obstacles here, like memory efficiency, and that just as a whole, JVM applications have a slow startup relative to the lifetime of a serverless function. And then we get into some Spark-specific obstacles like scheduling. And when I say scheduling, that's really kind of one and the same with resource allocation and with cluster management, because you're talking about, because you're really talking about what's controlling the life cycle of the Spark cluster, what's like Yarn or Mesos or now lately Kubernetes, you know, and of course the big gun, Shuffle, all about state. Where you're going to keep that state? And the answer, if you look online, is people really want that state. So you'll see a variety of different implementations putting it on S3, in message queues, in key value stores, and you know, as far-fetched as this may seem, the impulse clearly shows that people want a pluggable shuffle service as part of Apache Spark. And right now, that almost involves either forking Spark and adding it yourself, or going into something like Spark 3 and going into some Blinken Lights code to start getting that added. So it's by no means easy to get this done. So taking a closer look at stateless functions, the very simplest Apache Spark, serverless Apache Spark that you could imagine would be like a standalone Spark server running in a stateless function. Just imagine that it pops up, it does something really simple, and then it goes away within whatever, 5 minutes, 10 minutes. I've just got here like a summary of what some of the current limitations are, and you can pretty much see from the memory limitations that you're going to have to turn sideways and suck it in to make your deployable under the limitations here. I've got also here like OpenWhisk and Oracle Cloud. Like these are all. It doesn't matter back and forth. You can see like choose your poison. It's going to be a little difficult to get this working. So so essentially, you've taken something that was developed to process very large data sets, and now you are introducing the idea of time and memory constraints, and now we have to worry about the size of the deployable, which if you build a fat Spark jar, like lots of people do, you know it's a big jar. Really, but at the same time, once you have a Spark ecosystem for processing large data sets, why wouldn't you want to use that to process small data sets too? I mean, why not? It's only that Spark wasn't evolved to do that now. So let's consider an example of some embarrassingly parallel operation. So just imagine that you were using AWS step function or something like that and just launching a number of standalone Spark services to deal with that. Like let's say that you're running some type of very parallel ML model or something like that. So you've just got it. Running in parallel. You don't really even have a cluster manager or anything. Everything's just running standalone. So that could work, right? I mean, every ML model for itself. That could be, there are actually some implementations in the wild that do this now. But most Spark jobs are Spark jobs because they're a lot more complicated to this. So what if it doesn't fit into a single function? What are you going to do then? So you need to consider what if you've got multiple stages in order. You know, like that is really what a Spark cluster manager exists to do. We're talking about scheduling, about allocation, about managing tasks and making sure that they succeed or failing the entire Spark job. You can't really do that very easily with a step function, right? Or sorry, you can't really do that very easily with serverless workflow management. So considering that, like what is the simplest thing that could possibly achieve this? It's not good, but it's kind of an idea, right? So we have the same idea that we had before, that we're just launching a bunch of standalone Spark services, standalone Spark servers and stateless functions, but now we're going to use a step orchestration, and we're just going to kind of launch them and make sure that they succeed. And if they don't succeed, we'll launch them again. So that's really very primitive. And we can also use that to split data up if we have to. And this is terrible, but it kind of gives you an idea that, well, maybe you can. Maybe you can do this. So really, more viable options would be to run it on a serverless container like AWS Fargate, because that doesn't have a time limit and you've got significantly more resources. So in practice, this workflow usually involves having the trigger hit a serverless function, which then kicks off the serverless container. But or you could use serverless workflow orchestration. You could use a purpose-built cloud provider offering. So essentially, there's a variety of data processing pipelines that cloud providers just offer, so that, like Legos, you just stack up the different services. I don't hear very good reviews of those in person, but I do read blog posts that sound enthusiastic about them. Or finally, the most interesting one, you can delegate cluster management. So for serverless containers, you've got a variety of options now. Fargate is, all right, it's kind of expensive now, but it will come down in cost over time. And Google Cloud has an offering. So does Azure. It's serverless orchestration is another hybrid approach, because it's the coordination of the pipeline that is serverless. So the actual Lambdas could be launching anything, really. And if you look at accounts online, you find pretty much just a lot of really interesting things being nailed together. Yeah, that's what I love about data engineers. They're determined to get to the end of the pipeline one way or another. So, all right, and then you've got services like AWS Glue, which is fully managed, and Google Cloud Dataproc is actually, from a serverless perspective, the most interesting one, because they actually do have a working external shuffle. And what they're using for that is distributed NFS. So there was a presentation I've got linked in the resources at the end, where they explain how they evaluated different external shuffle data store options and came to the answer as distributed NFS. So, and it just came out running containerized on Kubernetes like a month ago, maybe 2 months ago. So this is really technically interesting. And also, Microsoft is not far behind. They're offering Microsoft Data Accelerator for Apache Spark, which works with Databricks and also Azure's own HD Insight. So serverless offerings are coming up on the cloud, which certainly cut down on the, it's still a bit experimental doing it yourself. So, and then finally, delegating cluster management. So Kubernetes Kubernetes now is natively supported in Spark, and this is an opportunity to take I think everyone was using Yarn until pretty recently. And even if you were unhappy with Yarn, it was, what were you going to replace it with? Mesos? But Kubernetes has had, all right, it's not fully baked if you're still using Spark Submit, but it's starting to become a bit smoother, especially in Spark 3. They are looking at they're looking at making dynamic allocation actually useful, and that is a huge hot topic right now, because the problem with dynamic allocation is it's assuming that when the cluster is up, those nodes stay up forever. If if dynamic allocation identifies that the node is unused, it doesn't spin the node down. It just makes it available to a different job. But in a serverless world, what I want to do is get rid of, if that node is unused, I want it to go away. And downscaling is a hard problem. So you can kind of see some tickets here and sprinkled about, a lot of discussion how to make downscaling seriously work so that nodes can be shut down. And kind of an extension of serverless would be, well, wouldn't it be great if you could turn a Spark executor into a stateless function, and that way when you're done with it, it goes away. If you've ever stared at a cluster that was running a job with skew and seen 2 nodes active out of 1,000, then I think you'd probably understand the desire to do something like this. It could save a lot of money on cluster costs. So Kubernetes doesn't support that right now, and it doesn't support external shuffle right now for reasons that, if you start looking at shuffle, it's not pluggable in Spark right now. But if you look at the Spark, if you check out Apache Spark and look at branch 3, you can see some interesting developments. People are trying to fix this. Palantir has some contributions. It's not something that you can just use right now easily. So what can you use right now? Well, cluster management that is built on top of cloud providers. So Databricks have been doing serverless since 2017. They offer optimized auto-scaling, and that's a feature where you can just tick a box and enter some parameters. Kubel is probably, from a technical perspective, the most interesting one because they've figured out how to run a whole Spark cluster on Lambda. So that's obviously, you have to hack up Spark quite a lot to make that work because, for one thing, serverless functions can't address each other. So how does a Spark, yeah, I've got a link to some of their code in at the end of the presentation because just seeing some of the things that they did to make that work is just an interesting look at the underside of Spark. So now, going back into the engine room, just taking a look in detail at changes in Apache Spark to support serverless. The shuffle problem is that shuffle blocks are stored locally on the node. So if you're running a single executor per node, your executor and your node are synonymous, but it becomes a bit blurred when you're using something like Kubernetes, or you don't really necessarily understand or control per physical node or per container what executors are there. So you can run into issues where executors can be shut down, but they're sprinkled across different containers. So can the container be shut down? No, because you have 3 nodes running in 3 different containers, not 3 nodes on 1 container, allowing you to shut down 2 different containers. Another problem that you can run into is that, at least if you were running Spark inside a serverless function, they all have buried deep in the documentation limitations on the essentially IOPS. So since Shuffle generates a lot of intermediate files, you could actually blow your resource limitations if you were shuffling a lot. So the most interesting approaches are looking at writing externally all the time is really expensive, right? I mean, even the fastest key value store is going to be a lot slower than writing to local storage, assuming that you have it. So they're taking looks at running with attached or accessible local storage, what have you, EBS volumes, SSDs mounted, whatever, and then only move it externally off the node when you absolutely have to. So there's some of that in the Spark 3 branch. So Now for auto-scaling, yeah, I kind of covered some of the stuff on this slide. But something which doesn't seem quite ready for prime time, but is super interesting, is Apache Graal. It's an incubator project where you just use direct memory access. So no more external storage, just everything directly accessing everything else's memory. It sounds super cool, runs super fast, and from what I've heard, is not super stable at scale yet. But imagine that. I mean, that could just get rid of the external storage problem entirely. So now, finally, the scheduler problem, like why these things keep converging is because when you touch resource allocation, you know, like you're talking about, so the Spark scheduler is hidden deep down into the stack. To change the scheduler, you have to fork Spark. And it's, you know, the Kubernetes contribution was a major open source improvement, but you know, different cloud providers could offer different optimizations specifically for their own Kubernetes services or what have you. If the scheduler could be made pluggable, then you can choose the best one for you. For instance, the Kubernetes scheduler in Spark 2.4 is known to have issues with starvation. There's actually a presentation by Palantir which referred to it as the clown car scheduler. So I've got a link to that presentation at the end. But I think being able to choose your scheduler, to choose the scheduler that's best for your cloud provider and for your job would be a necessity for a serverless Spark. Now, if you're interested in knowing where's the ongoing discussion about this, here are some links to some tickets about that, and also more abstraction. Why should you even be tied to Spark? Apache Beam, which is another layer of abstraction on top of data processing jobs, has this idea, all right, Spark is just one runner. Maybe you want to use different runners. And that's actually available now on Google Cloud Dataflow. So looking ahead, besides decoupling storage and compute, which is really, at the end of the day, what we're talking about with serverless Spark, I want to talk about GraalVM, because if we can solve the shuffle problem and we can solve the scheduler problem, then what can we do to make Spark start up more quickly, use fewer resources, run faster? And part of the answer, in my opinion, is running with GraalVM and getting to a native image. Now, is everyone here familiar with GraalVM? Have you heard about it? You've seen some, I mean, there's been a lot of very cool presentations in the past 2 or 3 years especially about it. But essentially, you can use it to compile JVM code. It's much faster. You can use it to run JVM code. Depending on what you're doing, it's kind of faster. But what a native image does is it gives you the ability to run machine code from startup onward. And what we're really talking about here is the difference between just-in-time versus ahead of time. So what you have with a normal VM, with a normal JVM, with a normal compilation process is, all right, you've got your code, and you know, when it starts up, everything just gets loaded up, it gets parsed, verified, whatever, and then when you start running your application, that is when the just-in-time compiler is going to start looking at the stuff that runs a lot, is quote-unquote hot, and then eventually it's going to turn that into optimized native code. But that eventually could be a very long time for the lifetime of a serverless function. So ahead of time compilation is everything is native up front. at compile time, and it can perform optimizations which just take too long for JIT compilation. So the trade-off from that, you'll see a link here to certain limitations. I've been trying to, I would really like to see a native image of Spark. And if you have any idea of what the limitations are, namely, reflection is a huge one. Code generation, all right, at compile time, that can be dealt with, but there are just a number of limitations with some of the older and weirder code in the stack. So it's you know, I think it's definitely going to be an effort to get a native image, but it's something that I really want to do because that opens up a possibility of using far fewer resources to run. So imagine, even just if you're running Spark conventionally, imagine how much you could save over repeated runs of the same job. So not exclusively serverless, but another possible improvement is, you know, I'm a Scala developer, and but actually a lot of people who use Spark are Python developers. It's an ML world out there. And you know, conventional wisdom has it that, you know, all right, so fine, it is slow. The interoperability cost of using Python with Spark is something, but everyone always says, oh, it's not the slowest part, or what have you, which may be true, but we don't really know that. And what about developer experience? Is that cost nothing? I don't think it's nothing. So I think that being able to use Graal Polyglot support could drastically improve the Python experience on Spark. Honestly, I don't know really. I think that at least a couple of people or companies are working on this, but I don't think anyone has significantly progressed yet. But I have seen a blog post from Oracle mentioning specifically compiling Spark, so I think someone might be working on this. So that gives me some hope, because my end game here would be turning Spark executors into serverless functions, which would somehow, once the shuffle problem is solved, be able to persist the shuffle state wherever you want. You can choose. Distributed NFS sounds pretty good to me. Everything old is new again, I suppose. So, and then you can run it where you want. You can choose the cluster management, but you can spin up and down these serverless functions as you want. Let's just say that the limitation increases. Lambda used to be 5 minutes, now it's 10. Eventually, it could be long enough to support the lifetime of an executor for the stage, you know, for an average Spark stage. So, and the compute, well, I mean, serverless functions could be a bit too optimistic, but let's say containers. I mean, the whole idea would be that when you're done with an executor, it doesn't hang about just because another executor is doing something. You know, it doesn't sit idle. It could bring about scheduler improvements, which would allow us to keep clusters running hotter. So anyway, that's my idea with serverless Spark. So I'd like to open up the floor to questions. All right, and my slides are already up on Speaker Deck, and if you're interested, come and find me. So.
Do you think to achieve this, that the Spark team will need to come up with a form of moving the scheduler to executors so that they can poll for tasks rather than being push tasks in the current execution model?
Yes. Essentially, the way that's being got around right now is that the executors are kind of being launched with parameters with some type of parameter that tells the app you're running on this chunk of data. So it's kind of, yeah, I don't always rewrite the Spark master, but when I do it in a Java, I do it in JavaScript and, you know, in a JSON, so. Yeah, I will say I've anecdotally heard an account of Spark Spark executors which communicate using SQS and Amazon for this purpose. So that's another way. You know, in other words, if you make serverless functions not addressable, people will find a way to make to communicate. So.
Have you seen any examples of people writing custom file protocols to dodge the issues with shuffle service portability, to hack around it, or do you think most people are going to be waiting until the shuffle service is actually a pluggable interface?
I think there are so many different solutions anecdotally I've heard about. When I attended Spark Summit, I was kind of asking everyone, you know, are you running Spark serverless? And I heard back a lot of interesting answers. You know, kind of. Some of the work is non-public just because you essentially have to, if you want to do your own thing just to scratch an itch to run serverless, either you can go through a very extended process with making an open source contribution to Spark, or you can fork it, write your own very lightly reviewed implementation of Shuffle Server, and go now. So I think that there's a lot of that in the wild right now. But in Spark 3, you see some kind of larger companies which have the time and, you know, kind of focused open source developer effort to make contributions back to Spark, you know, through an open source channel, kind of adding in some really interesting ideas. And I got to tell you, every single one of these is marked, do not use this, will change. Blinking lights, don't, but just look for the external shuffle service and look for implementations of it. You'll see Palantir in particular has a big change set around that. So the whole idea, Palantir's whole end game is to make dynamic allocation work on Kubernetes without requiring an external shuffle service. So, which is an interesting direction, you know. I'd like to take that in the other direction and say, hey, once you're putting the files externally, why does the external shuffle service have to live on each individual node? Why can't it be centralized the way the Spark master is? Scale it out, have a bigger RPC pool, something like that. Have a couple of them, pool it, you know, like, I think that the communications in the Spark cluster are very adapted to a certain point in time, a thought of having an always up cluster or a single purpose cluster that runs for a long time. And it's kind of a paradigm shift to think of, hey, you need to decouple having all of these resources located on one box. So, and you know, it's not criticism to say that the people who wrote it didn't foresee this happening. It's just kind of an evolution, you know, so. Yeah.
So Apache recently added the support for like serverless Lambda computation, right?
Yes.
How did they get around the problem of shuffle? How did they solve that?
Apache Flink. You know what? I read something about that recently, but I'd have to go look that back up, to be honest with you. I think that they're serializing the state externally. I can tell you that much. So. Oh, okay. All right. Sorry, we're running over a little bit. I'm sorry, but I will be happy to answer any other questions outside. So, thank you so much.
Thanks, Rose.